Welcome, my friends. So, today I am going to discuss GFG problem of the day. Okay, so today's problem of the day is binary matrix having maximum number of ones. Okay, so I will read first the statement of the problem, then I will discuss various approaches to solve the problem. Okay, so given binary matrix of order n cross n, all rows, okay, all rows are sorted already. It means that the rows are given in sorted order from like increasing order. Okay, we need to find the row with maximum number of ones, also find the number of ones in that row. So the statement is very much simple. We have to find the row which has the maximum number of ones, and also we have to count the number of ones present in them. Okay, so here we have a short note. In case of type in the smaller row number, okay, so it is pretty simple, and row number should start from the zeroth index. It means that the matrix is in the form of zero addressing. Okay, so now let's see some examples. So I have taken already some examples previously. So let's see. So as you can see, the first row, what is the number of ones? It is 1. It is 1. Okay. And in the second row, the number of ones is 2. And in the third row, the number of ones is 0. So the maximum is the second row, whose index is 1. So we have to return the index number. Okay, so it is 1 in this case, and number of ones present in that row, that is 2. Now let's see for the second example. The second example, in the first row the number of ones is 1, and in the second row the number of ones is 2, and in the third row the number of ones is 3. So maximum is this row number. Okay, so we have to return the index of this row, which is 2. Okay, 0, 1, 2. So it is 2, and the number of ones present, it is 3. Now, in my last example, as you can see, here is a 4 cross 4 matrix. The number of ones present in the first row is 2, second it is 1, third it is 0, and fourth row has number of ones is 4. Okay, so maximum is this row. We have to return the index of this row, which is 3, and number of ones present is 4. Okay, so 3 comma 4 will be the answer. Now, let's see various approaches to solve this problem. Okay, so the first approach that I want to discuss is brute force approach. Okay, so what we can do in brute force approach, we will run two for loops. Okay, for I to n minus 1, and another for loop for j to n minus 1, and I will take one count variable. Okay, so count variable will store maximum number of ones, and another variable index, which will store the row index. Okay, row index which has maximum number of ones. So in the second for loop, the for loop that is inside the outer for loop, we will count if mat of ij is equal to 1, then I will take here int cnt equal to 0, then cnt plus plus. Okay, cnt plus plus. After the end of the for loop, if cnt is greater than count, then what I will do, I will update the count as cnt, and the index will be here I. Okay, very simple, very simple. And finally, I will return a vector which will contain the index and count. Okay, so this was my brute force approach. Okay, now I will discuss with you the most efficient approach. So another approach that can be done is binary search. Okay, binary search. If you see the brute force approach carefully, it have a total complexity of order of n square. We can reduce it to order of n log n. Okay, how we can reduce? Let's see one example. Let's suppose this is my first row, this is my second row, this is my third row. Let's suppose it has this type of arrangement. Okay, let's write the index 0, 1, 2, 3, 4, 5. What we can do here basically, we will apply a binary search for this row. Okay, so my low, I will take two variables, low and high. Initialize low with 0 and high as n minus 1. Okay, now I will run a binary search while low is less than equal to high. Okay, so I will first calculate the mid, which will be low plus high by 2. And if my matrix of index, okay, matrix of, sorry, not index, let's name it another variable. If matrix of row and mid is equal to 1, then if this let's suppose 0 plus 5. Okay, so my low is 0 and high is 5, so 0 plus 5 by 2, 0 plus 5 by 2 will give us 2. Okay, so I will check if 2 is 1. So in this case it is not 1, so I will check for higher values. So low will be initialized to mid plus 1. Else, if mat of row mid is equal to 1, then I will update high will be equal to mid minus 1. And what will be the count of ones? Let's take another variable cnt equal to 0. So what cnt equal to 0 specifies? Cnt equal to 0 specifies the count of ones is that particular row. Let's suppose my mid has come here. Okay, so mid is equal to 4. And so what is the number of ones from this range? Just one second. What is the number of ones from this range to this? It is equal to 2. So how we can get the number of ones? So my count will be equal to maximum of cnt comma n minus mid. Okay, here n is 6, n is 6, mid has a mid value is 4, so 6 minus 4 equal to 2. In this way, for we will apply the binary search, and my final count value in this example will be 2. Oh, sorry, 3. Okay, and what will be my code of this approach? So for row equal to 0, row less than n, row plus plus, row plus plus, and the whole thing will come inside of here. Okay, whole thing will come inside of here. And again, if cnt is greater than count, then I will update my count will be equal to cnt, and my index will be equal to row. Okay, so this was my second approach, that is binary search. Now another approach which is the most efficient. So first we saw that from order of n square we come to order of n log n. Okay, but now I will discuss an approach that only takes order of n time. Okay, so let's see how we can do it. So let's continue the example. Let's suppose my given matrix in this form. Okay. So what is the count of number of ones is first row, which is this is 1. Second row is 2. Third row is 1. And final row is 3. So my the row with maximum number of ones is the index with 3 and the number of ones is 3. So my output will be written as 3 comma 3. So up to that, this is simple. Okay, now let's see what is my final approach. See, I will take one variable name as j, and that I will initialize with n minus 1. And another note, my given matrix in form of n cross n. Okay, it is always a square matrix. So I will initialize j equal to n minus 1. Then I will run a for loop for I equal to 0, I less than n. What I signifies here? I signifies the row index. Okay, so it is from 0 to n minus 1. Now I will run a while loop. Okay, while j is greater than equal to 0. Okay, and mat of ij is equal to 1, then I will do j minus minus. Okay, j minus minus, and I will initialize two more variables, that is the index and count equal to 0. Okay, both with 0, and I will simultaneously do count plus plus. And if cnt is greater than, okay, sorry, 1 second just. Okay, friends, so I will take here another variable boolean flag is equal to false. So this is just like a marker. Okay, and if mat of ij equal to 1, then I will also do flag equal to true. Okay, flag equal to true, and not writing this code if I find that 1 is present in any of the row, then I will update index as I, and finally I will return index comma count. So now let's uh, try a dry run of this code. Okay, so in the first case, my I will be equal to 0, j will be equal to n minus 1, that is 3. Okay, n here is equal to 4. So first I will enter this line. So flag is initialized to false, no problem. Then I will be put under this while loop. So while j greater than equal to 0 and mat of ij equal to 1. So j is greater than equal to 0, and I will check mat of ij equal to 1. Is mat of, yes, 0 3. Mat of 0 3 is 1. Okay, so count will be updated to 1. Flag will be updated to true. Okay, flag will be updated to true, and j will be decremented. So j's new value will be equal to 2. Okay, simple. Then as j is greater than equal to 0, 2 is greater than equal to 0, I will check if mat of ij equal to 1. So mat of 0 2, let's mark the index 0 1 2 3. Is mat of 0 2 equal to 1? No. So I will break from this while loop, and flag is initialized as flag is true. Our index will be updated to I, and I is 0. Okay, so now I will become 1. I will become 1. Again, my flag will be initialized to false. Okay, initialized to false. Then I will again enter in this while loop. Yes. Then I will again enter this while loop. And is my j greater than equal to 0? Yes. Is mat of ij equal to 1? Yes. Mat of 1 comma 2 is equal to 1. So my count will be incremented. So count will be incremented from 1 to 2, and flag will be initialized to 2. Flag will be updated to 2. Okay, flag will be updated to 2. Then again I will come in the while loop as big, and j will be decremented, right? J will be decremented from j equal to 2, it will be 1. Then again I will come to this while loop as j is greater than equal to 0, and I will check if mat of 1 comma 1, mat of 1 comma 1 is 1. No, it is not. So I will break from this while loop and I will check if flag, yes, flag is true. So my index will be I, so it will be not 0, it will be 1. It will be updated to 1. Then again I will go to this for loop. So my I will be now not 1, but it will be 2. It will be 2. It will be 2. Flag will again, flag will be initialized to false. Index is 1, count is 2. Now again I will go in the while loop as j greater than equal to 0, and I will check if mat of ij equal to 1. If mat of 2 1, 2 1 is 1. No, it is not. It is not. So I will break through this while loop and I will check if flag. No, flag is already false. So my this inside portion is completed. Then again I will be incremented. So now I will be incremented to 3. I will be now incremented to 3. J is already 1, flag is false, count is 2, and index is 1. Okay. So now again I will come to this while loop. Now we will check while j greater than equal to 0. J is 1, so it is greater than equal to 0, and mat of ij equal to 1. Mat of ij. So I is 3, mat of 3 comma 1. 3 comma 1 is 1. See, 3 comma 1 is 1. So first I will decrement j minus minus. So j minus minus from 1, it will be 0. Flag will be true, updated to 2. Count will be 3. And my index, oh sorry. Now this while loop is completed. Again I will check is j greater than equal to 0. Yes, mat of ij 1. So it is not 1. Okay, it is not 1. So I will break from this while loop, and if flag is 2, so my index will be updated to I, and I is what? I is 3. And finally I will return 3 comma 3. So I hope you have understood the approach for this problem. Now I will jump to the coding part. Okay. So first I will initialize some variables I, j, comma k. Then I will initialize j equal to n minus 1. Then I will run a for loop I equal to 0, I less than n, I plus plus. Then I will take a flag variable bool flag equal to false. And while j is greater than equal to 0 and mat of ij is equal to 1, then I will decrement it, update flag equal to true. Okay. So I have to take two variables, int index equal to 0, count equal to 0. Okay, count equal to 0. So my count will be incremented count plus plus, and if flag, then I will update the index as I. Update the index as I. Okay. Now I will finally take a vector. No, so not no required of vector. Okay, so I will return the index and count. And another test case is there. So if my array is like this, 0 0 0 0, so we have to just return 0 comma 0. Okay, Okay, so it is one of the base cases. If the matrix contains only zeros, then I have to return 0 comma 0. So let's run this code. So my output and expected output is same. I will just submit the program. So thank you. If you have understood the problem, please considering liking this video. Okay, liking the video. If you are new to this channel, please subscribe. Okay, and if you understand this problem, it is very important that you write yes in the comment. Okay, yes in the comment section. Okay, and please share this channel. Okay, and take my love with you.